Hi guys, I'm Sahan HV. I'm from the Department of Computer Science, Ramaya Institute of Technology. I'm here today to present my seminar on Compute Unified Device Architecture, or CUDA in short form. For those who don't know what it is, CUDA is a parallel computing platform and a programming model that was developed by NVIDIA, and it uses the power of the GPU. Basically, it does fast computation. So I'll get more into that later. So before I go ahead, I just want to present an overview of what the seminar is about. So here's the overview. First, we'll go ahead with the introduction, where I'll introduce you guys to the parallel programming, its importance, and how it's gaining popularity nowadays, the GPU and its functionalities, and obviously the CUDA environment and the various tools of CUDA. Then we go into the installation of the CUDA toolkit. That is the version 8.0, which is the current version available on the NVIDIA website. So we'll go ahead with the installation of that. And after the installation, we're going to demonstrate. We're going to write our own CUDA program on the Visual Studio, and we're going to run it. Yeah. And after that, I'll just summarize the stuff that's in the overview, and again talk about the future stuff that CUDA can be used in and stuff like that. Okay, so let's get started. Let us begin with an introduction to parallel computing. So as we all know, over the few years or over the last decade, the influx of data has increased tremendously. So you need more efficient methods and you need faster processors, obviously. So for economic reasons. So how do you make a processor faster, right? Before we go into this, what is a processor? A processor is equivalent to a human brain, right? In a computer, it gives the rest of the units all the instructions and it just coordinates all the activities. So first method of doing this is using a faster clock. This basically means doing the work faster. Like take an example, like if you want to dig a well in your backyard, the faster you dig is the faster you get your well. So a faster clock is analogous to you digging once every 2 seconds rather than you digging once every 4 seconds. So the work gets done faster. An advantage of this is obviously it saves time, but the disadvantage is it uses more power. Okay, the second one is more work on each clock cycle. So imagine you're using a shovel to dig your well, and you get a bigger shovel, like that's twice the size of the shovel you're using now. So obviously on each clock cycle you're removing more dirt from the ground in your digging, so it becomes faster. Again, this one uses more power. Obviously you're going to spend more effort lifting that bigger shovel, right? So, and the third one is what we're going to focus on, more processors. So okay, fine, you're digging and you get bored and you think the work's headed nowhere, so you call your brother and your sister to come and help. So what you're doing is you're increasing the workforce, so the work gets done faster, right? This is nothing but parallel computing. You have a large workload and you divide that workload into smaller portions, and you use more than one processor to deal with it. So this obviously saves time and it's much more efficient than you doing it serially or you're doing it alone by yourself. There's nothing new with parallel computing. It's been happening all around us. Like you can see in nature itself, the planets revolving around the sun takes place simultaneously. They're synchronized and it's independent of one another. So a lot of stuff, like nowadays you have Google searches, you have database transactions online. All of these, they use parallel computation rather than serial, obviously for what economic reasons. Faster it is, the more money you save and the more time you save, right? And everything nowadays, you have internet marketing, you have internet banking, you have other real-time business collaboration. All these require parallel computing. So one of the most important aspects involved in parallel computing is the GPUs, that is the graphic processing units. Okay, so what they do is a CPU just it processes stuff serially. So the GPUs use multiple cores and multiple threads, and they do parallel computation. So obviously they are faster. So usually in the earlier days only supercomputers used to do stuff in parallel, but nowadays the GPUs are available to everyone, so you can have one in your house as well. So what are the main aspects of a modern GPU? First of all, it uses thousands of ALUs. ALUs are arithmetic logical units that help in arithmetic calculations. And then there's hundreds of processors, yeah, for parallel computing, and that has tens of thousands of concurrent threads. So what are these threads? Threads are nothing but pieces of work. Okay, so yeah, again the workload which is done simultaneously. These threads they execute in parallel, doing part of the work, and then they synchronize at the end to complete the work. Okay. Now we come to the main question, right? And it's here on screen. What is CUDA? Well, CUDA or Compute Unified Device Architecture is a parallel computing platform and programming model that was invented by NVIDIA, and it leads to a dramatic increase in computing performance by harnessing the power of the GPUs. So mainly CUDA was developed for two main reasons. First is provide a small set of extensions to standard programming languages like C and C++. So CUDA programming it can be written in C and C++, and while the C program is executed on the CPU, the various extensions of the C and C++ are executed on the GPU. So it works simultaneously. And also, yeah, to support a heterogeneous environment. A heterogeneous environment is a device which has a CPU as well as a GPU and the coordination between the two. And CUDA capable GPUs, they have a lot of cores. They have hundreds of cores, like the one over here. The one that I have is the NVIDIA GTX 960M, which has 640 CUDA cores. Okay, and then obviously they have thousands of threads that work together to increase the performance, right? So CUDA is a platform that exclusively runs on NVIDIA graphic cards. That's pretty selfish on their part, but like it really doesn't matter, does it? Yeah. So what NVIDIA claim is that it's not just a programming model. CUDA is more than that, right? It's used by researchers for so many things. There's supercomputing, seismic processing, fluid dynamics, computational chemistry, molecular dynamics, computational finance. All CUDA can be used. It has an extensive platform, like with a lot of functionalities. So let's go ahead with the installation of the tool CUDA toolkit, which is available on the NVIDIA developer site, and let's write our own program and see how it all works. Okay. Now let's go ahead and install the CUDA toolkit on our computers. So before we go into that, my advice to everyone is to look at the documentation, because there's a lot of stuff you need beforehand before we start the CUDA installation. So this is the CUDA toolkit documentation, that is the installation guide for Windows. How do you get it is just go to Google, type CUDA toolkit documentation, and there's CUDA installation guide here exclusively for Microsoft Windows. Just click on that and you will come to this page. So basically this just gives an overview at the end. It's sort of an introduction to CUDA. And then what really is important to note is the system requirements, because CUDA doesn't work on all systems. Okay, so you first of all you have to have a GPU. if you try installing it without a GPU, it just doesn't work. And if you don't, and even in the GPUs, it mainly works on the NVIDIA graphics cards. Any other graphic cards, I don't think. I think it's close to impossible. You could make it work, but I don't. Yeah, it's impossible. It won't work. So you need an NVIDIA graphics card, and you should make sure uh, go to the control panel and make sure this your graphics card is turned on. Okay, in the control panel the graphics card should be turned on. Okay, good. Okay, so firstly, the system requirements, you need a CUDA capable GPU. That's mainly this. What it just means is that it's an NVIDIA GPU that they need. Okay, a supported version of Microsoft Windows. So if we come down over here, these are the various, like Windows 10, 8.1 and 7, they all support CUDA, and the some of these servers as well. So you do need a support version of Microsoft Windows. So, and you need a support version of Microsoft Visual Studio. So there's an integration between the CUDA toolkit and the Microsoft Visual Studio, where most of the programs are written in Visual Studio. They run on Visual Studio using the CUDA SDKs and stuff like that. Okay, so it's best if you install a Microsoft Visual Studio like beforehand itself, before installing the CUDA toolkit. Yeah, and also in this thing, if you Google the Microsoft Visual Studio, yeah, so Visual Studio. So you just go to this website where you're supposed to download the Visual Studio, and you see the Visual Studio 2017. So most of the times, like most people just don't read the documentation, just install whatever that is, just see maybe the system requirements, and they go ahead, like even like say a person like me, I hardly read the documentation, like I just want to install stuff anyway. So you might just go and install this. Visual Studio takes a long time to install, so maybe a half an hour. You might just install, and then you might install CUDA, and then search for Google saying, oh, my CUDA doesn't work on this. Yeah, clearly, because again in the documentation it gives you a set of Visual Studio versions that it supports. So the Visual Studio 2015 is like by far the latest that the CUDA 8.0, that's the latest version, supports. So you should go ahead and get that. The Microsoft Visual Studio, like, it's not available here. Uh, on the Visual Studio site, you gotta, like, I think you gotta pay for that. So you could just go ahead. Sorry, 15 download. Yeah, so this community one should be good. Okay, yeah, so you just click on this download, and you don't need the ISO file, just the exe file. You just click on next, right, and you get an exe file. Just save the file and run it. I'm not going to show you how to install Visual Studio. It's like a direct process. We'll concentrate more on CUDA. So this is the thing. So make sure that's there. That's the Visual Studio 2015 version of it. And yeah, you need the NVIDIA CUDA toolkit, which is available here. Just open this link, right? Yeah, this is the latest version that was released, I think, a few months back. That is the 8.0. And yeah, even they tell you to go ahead and read the instructions first before doing everything. So okay, then you choose your operating system. Mine is Windows. Yeah, x86 64-bit, version is 10. And yeah, I'll just go ahead with the network exe. It's a 24 MB file. Okay, 25 mostly. So I just click on that and save file. Good. It's probably, yeah, takes around 30 seconds. So again, it's important to look at the documentation where they tell what all requirements you need before installing CUDA, going over to the installation. And earlier you had to install the SDKs and drivers and all separately, but now I think the toolkit nowadays it covers everything. So yeah, this should be about done. Yeah, this is done. So okay, now the download is complete, so we can go ahead and run this file. So just open up to wherever you have saved it. Mine is in downloads. So now just all these are the same. This was downloaded a few weeks back, so I think this is a better version of it. I'm not sure. Okay, so just click on it, and yes, so where do you want to install it? My C drive is full, so I'll just go ahead with D drive and CUDA, right? Okay, so this is pretty fast. Depends on your system as well, how fast your computer is. Yeah, it checks the system compatibility, or yeah, like I said before, it needs an NVIDIA graphics card, so this could take a while before it begins installation. So after this it's just a series of next, so it's pretty simple. So another cool thing that could be checked out is the CUDA zone, which is for the NVIDIA developers. So there's stuff what the CUDA toolkit can do, and they train you on stuff. Various downloads, they're mainly sample CUDA programs, the other tools. It's like it's a developers community, and yeah, it's pretty. Yeah, see, that's it. Okay, fine. That thing's done. Yeah, this is the license. No, no one reads it anyway. Just scroll down and agree and continue options. This is done. Next. Okay, the following processes must be stopped. Okay, sorry, the Visual Studio was open. Yeah, next. Yeah, that's it. So this could take a while. It probably takes around half an hour to install, and the system also has to restart. So I will pause the video and I'll come back later. Okay, cool. Okay, we're back again, and that took a lot of time. It takes, depending on your speed, it takes around half an hour to install CUDA. So now we're back again. So this is what you'll get after everything's installed. So as you can see, I have the Visual Studio 2015. So the modules have been installed for that, and the remaining have not been installed. And as I said before, for the Visual Studio 2017 and the 16 version, there is no CUDA compatibility. So if without reading documentation you download that and you try and install CUDA and try and this thing, it will not work. Okay, so this is the screen you get. You just click on next and stuff like that. Okay, cool, this is all fine. Yep, close. Okay, and now we can go ahead and start off CUDA programming using the Visual Studio. Okay, this is just a showcase showing the various CUDA drivers and all that in this thing. You don't require this. So next we will launch the Visual Studio and we'll demonstrate how to run CUDA programs. Okay. Yeah, let's go ahead and look at the CUDA programs now. So first you need to go to the Visual Studio. Yeah, here it is, Visual Studio 2015. You gotta create a new project, file, new project, and here you will see that the NVIDIA uh, toolkit is already installed. Okay, suppose this option isn't there, then you have done something wrong with the installation. Either you're not installed it completely, or uh, there is no integration. Okay, towards the end of the CUDA toolkit installation, there's an integration with the Visual Studio where it recognizes the Visual Studio and it installs certain drivers in it. And in case that doesn't happen, then you got to reinstall CUDA. Or there's some compatibility problem. So probably your version of Visual Studio doesn't support the CUDA toolkit and the various drivers. So you need to make sure you have the right toolkit. Okay, so yeah, that's about it. So you're going to work on the CUDA 8.0 runtime. You can enter whatever you want project. I have already created a project, so that really isn't necessary right now. So I will go to my project. Yeah, here it is. So this is a CUDA program with a .cu extension. Yeah, so what it's basically a C program. So what CUDA does is it allows you to write program in C and C++ with certain extensions. Okay, those extensions enable you to compile it on the GPU, while the normal C code and the C plus or the C++ code helps to compile the program on the CPU. So you have the CUDA.h extension which you need, and the stdio.h and the stdlib.h extensions which are normal C files. Yeah, okay. So then you hear this is called a kernel, which has a global extension. That means it can be called anywhere. Basically this is function which will be run on the kernel runs on the GPU. So CUDA, what it recognizes, the CPU and GPU as co-processor, where the GPU is the co-processor of the CPU. So they work hand in hand, right? So the CUDA recognizes the GPU as and calls it the device and the CPU as a host. So there has to be certain uh, transition from the host and to the device. Okay, so first where you give input in the host, that's where the regular C comes into play, and so then you got to copy the memory to the device where the computation takes place, and then again you got to copy the stuff back to the CPU so to get the output. Okay, so this program is a simple addition of vectors problem where you just give input to two vectors and it computes the output, right? Okay, so this is a kernel which runs on the device or the GPU. So first what we doing is we initialize the host vectors and the device vectors. Okay, so before that I'll talk about thread blocks and grids in a CUDA platform. So the GPU in a CUDA architecture, it's divided into a number of threads. So the number of threads, they come together and form blocks, and a number of blocks come together and form grid, and a number of grids make up the device or the GPU. That's how it is. So you're initializing the blocks, threads, and you have the size and bytes. This mainly used for the device, is used for the host. So what you're going to do is these are the pointers to the vectors, the device vectors over here. That is initialized in the kernel over here. So yeah, so you're going to allocate using the CUDA function. You're going to allocate the memory, that is the bytes which is stored here, which is the size multiplied by the size of an integer. Okay, so you use CUDA malloc function to store to allocate the memory for the device vectors, right? So you give the input through the host vectors. So the first, you like suppose I say 20 and 5, and this one you initialize to 0. So now you got to send the uh, values from the host to the device, right? So this is how you do. You use the CUDA memcopy. So you're sending the values, the vector 1 and vector 2 to this. This is the source, the destination, and the size, obviously the size is in bytes, how much you have allocated, and you need this uh, sentence which is CUDA memory hosted device. This is inbuilt in CUDA. This has to be there. This is part of the CUDA memcopy function. So once it's there, you call the kernel, which is the add, and it just performs the computation that is the addition of vectors. So this, it works in the GPU. So this takes the device vectors and it adds the vectors and it returns it in the device vector 3, right? And you pass the number of blocks and number of threads which you have initially allocated, right, in the CUDA. Now once you get the answer, you got to send it back to the host, because this is how we see the output. So again, you do CUDA mem copy. This is the source from the device, you give it back to the host, and you have the CUDA mem copy device to host, which is in bold. This is necessary, yeah, and size in the bytes. So yeah, okay, you won't need this loop because we are trying only for the only one of the variables. So you print the vector that you get after computing, right? So you will run it, compile it, and run it. Yeah, it gives a few warnings, so this should be okay. So really, warnings are fine. And as you can see here, 20 and 5, we are getting the answer as 25, right? Yeah, so that should be good. Yeah, it works fine. So what we remember here is there are two processing units over here, the CPU and the GPU. So they have separate memory. What the CUDA identifies them to have separate memories, so we gotta do certain allocation of memories. And then obviously the GPU is a coprocessor of the CPU, so we so they work hand in hand. So we pass values using the CUDA mem copy from the hosted device, then again from the device to the host, right? And then we print the values in the host again. And this is the kernel function that runs only on the GPU. So most of the CUDA programs are similar, and what if more computation is required, you have a lot of threads. So we could put a loop over here which computes the various threads, um, computes the values using the various threads as well, right? Okay, so yeah, that's about it. This is a CUDA program which was executed and demonstrated, and yeah, that's about it. So as we come to the end of the video, let's just get an overview of what's been taught, or let's just recap. First, we were introduced to parallel programming and how it's come of importance nowadays, because it's very compute intensive, and almost all activities that are happening online, the real time stuff, everything, it's more parallel nowadays because it is more feasible. Okay, then we talked of the GPU, the graphic processing units, and how their multi-threaded environment is efficient to achieve those speeds. And then we were introduced to CUDA, the programmable environment, which was invented by NVIDIA and which harnesses the power of the GPUs. And we also learned how to install CUDA, and that CUDA requires certain uh, prerequisites. Namely, you need an NVIDIA GPU, without which CUDA doesn't work. Okay, so you need a supported version. If you're installing on Windows, it's possible on Mac and iOS as well. You need a supported version of Windows, yeah, and then you need Microsoft Visual Studio, yeah, to run the CUDA programs, and both of them have to be integrated. The versions, everything have to be integrated, and then you need the NVIDIA toolkit, which we downloaded and we installed, and then we ran a CUDA program, and we saw the relationship between in a heterogeneous environment